Welcome everybody. Just want to recap what we did in the last video and then introduce what happens during changes of state or phase changes. So what you can see in front of you should look familiar to you. There are some water molecules, and in between the molecules there are these weak intermolecular forces. Remembering that because of the shape of water, one end is very, very slightly negative and one end is very, very slightly positive, and that causes a force of attraction between the molecules. Now this is different from these thick black lines, which remember are the covalent bonds where the electrons are shared. So we're going to talk a little bit more in detail about these WIFs, or these weak intermolecular forces. So there's a bit of a difference between these WIFs when you've got a solid, a liquid and a gas. So in a solid, you've got lots of WIFs, and that's what holds the solid together in a set shape. So there are lots of weak intermolecular forces between the molecules. In a liquid, those weak intermolecular forces are reduced, so there are less of them. But they're still there, so they hold the molecule in place but allow the molecules to slide over each other. However, in a gas, there are no WIFs, okay? So there are no forces of attraction between the molecules, and that's why they can move apart from each other, okay? And that's why gases take up lots more space than liquids or solids. So that's just a wee recap. But this is the new part for today. So we call, when a solid changes to a liquid, okay, the word that we use to describe that is melting. So that's the name of the process that changes the solid to the liquid. So there are two words to describe this. It's either a change of state, which is probably what you're used to, or often it's referred to in this course as a phase change. So each state is called a phase. Okay, so change of state or a phase change. And you'll notice I've got just 3 water molecules here, and in a solid you've got lots of WIFs holding that solid in place, so holding the ice together if it's water. Okay, there are lots of WIFs. Now, when you change from a solid to a liquid, it's really important to know that heat energy is added. So you have to add heat energy. At the phase change, there is no change in temperature. So the average kinetic energy of these water molecules does not change. So where does the energy that you're adding in go? It goes into reducing the number of these WIFs. Okay, and so what happens is when you end up with a liquid, let me just draw a few in. Oh, that's a very unusual shaped water. Let's just forget that. And then we've got another water. So what happens is that you end up, so as the heat energy is continued to be added in, you reduce the number of WIFs here. So there are still WIFs, but there are less of them, okay? And that's what makes the liquid able to flow, if you like, because those molecules are still held together, but there are less WIFs. Okay, so the heat energy that you add in at the phase change is used to reduce the number of WIFs. That's a solid going to a liquid. Now let's look at a liquid going to a gas, and the name of the process that we call that is evaporation or boiling. And usually if you're adding in heat, like boiling the jug, we call it boiling. If it happens very slowly, like a puddle drying up, that would be evaporation. So we've got fewer WIFs because it's a liquid, and as you keep adding in heat energy, really important to know that you keep adding in heat energy. At the phase change, the temperature does not change. And the reason for that is because what's happening is the energy is going into actually breaking the WIFs. So that when you've got a gas, you've actually got no WIFs. Okay, so this heat energy is used to break the WIFs. So in a gas, you have no weak intermolecular forces, and that is what happens to that heat energy. That's why the temperature doesn't change. Okay. Going back the other way, a gas going to a liquid. This is cooling this time. Okay, yeah. So when we're cooling something, we need to remove the heat energy. Okay, so heat energy is removed, and the process in this case is called condensation. So what you've got is you've got a gas here, there are no WIFs between them. Okay, and what happens as you remove heat energy is the water molecules, or whatever molecules you're talking about, start slowing down. So they move more slowly, and as they start moving more slowly, then what happens is they come closer together, and you start getting WIFs formed between the molecules again. Okay, so when you cool something, you remove heat, and the phase change going from a gas to a liquid is forming WIFs. Not breaking them, the opposite of breaking them, it's forming WIFs. Okay, that happens at the phase change. And the last one that we need to talk about here is going from a liquid to a solid, and I've got a liquid drawn here with a few WIFs. Now that process is called freezing, and again you need to remove heat energy, and what happens is those particles slow down even more. Okay, and as you remove more heat energy, you increase the number of WIFs between the molecules, and then it turns from a liquid into a solid. So here you increase the number of WIFs. Okay, now to be able to explain that in an exam type question, you are looking at merit/excellence for being able to explain this. So if it is a little bit hard, that's why. Okay, please come and ask for an extra explanation if you need it. Thank you.